Hey everybody, today we're going to look a little bit more closely at the dilution portion of solution formation. So in a previous video I had talked about the formation of what are called standard solutions, where you add a solid material in here, you add a little bit of water, you shake it up, dissolve the solute, and then you dilute it down to this mark here, which you would make it to your total volume in your calculation. But what I want to talk about is going from the step from here to here. Because if you think about the solution, in the beginning, what we start off with is a more concentrated solution, and we have to dilute it down to this point here. So from this step to here, what we are doing is we are diluting the solution down. So dilution is going on here. What dilution means is that we're adding more water, not pollution. That's not a P, by the way, that's a D. Okay. Anyway, the idea is that we're adding more water to make the concentration go down. So if we look at molarity, molarity is the number of moles per liter of solution, right? So it's moles per liter. Well, if I go ahead and I increase the amount of water that I add, my volume goes up, and therefore my number of molarity goes down as a result of that. Because this becomes a higher number, I have more solution, and therefore, the same number of moles. And that's key right here, is that the moles don't change. Moles remain constant. Okay, so that's the thing to keep in mind when we are dealing with dilution, is that the number of moles are remaining constant. Now, just to refresh your memory on what moles tell you how much solute is in there. Remember, this is moles of solute. So let's make sure we remember that we're talking about at the top here are moles of solute. Okay, not the moles of solution, but the moles of solute. So let's back this up. What I did is I put a certain amount of solute in here, a solid amount. Well, if I measure the mass of that solute, right, if I have the mass of solute, couldn't I convert that to the number of moles of solute? Right? Once I put the number of moles of solute in here, that doesn't change. All I'm doing from this point on is I'm adding H2O. So I add water, and then from here to here I add more water. And that's pretty much all I'm doing, just adding more volume to this. So the key here is that I have two solutions. We can call this solution 1 with a molarity 1, and this would be a solution with a molarity 2. Okay? And we would have a certain amount of volume here. We would say this is volume 1, and this over here is my volume 2. Okay, so as I add the volume change, then I change my molarity. But what's remaining the same are the moles. So what's equal on both sides is the number of moles of 1 is equal to the number of moles of solution 2. Now, if you remember back when we first started talking about molarity, I can rewrite this equation and solve for moles. And moles would be equal to the molarity times the volume, right? Because if I multiply molarity, which is moles per liter, by the liters, the volume, these will cancel out, giving me my units of moles. And that's what I'm talking about here by taking the molarity. So if I multiply volumes by molarities, I get the moles. Here's my point, is that I can take my number of molarities that I have, the molarity and the volume, and I can multiply those together because molarity times volume is equal to moles. So what I'm doing is I'm replacing this with the equation here. So this would be a 1 and a 1 and a 1. Since these two are equal to each other, I can rewrite it that way. I could also say my molarity 2 is equal to my volume 2. And this is what's known as the dilution equation. Okay, so this is my dilution equation. We're going to use this when we do dilution problems. Because what I need to know in a lot of these problems is I'm going to want to make this solution. I'm going to say, you know what, I need a 110 milliliters of a solution that has a certain molarity. Maybe the molarity for this is equal to 1.2 molar. Okay. Well, the solution that I'm going to start with, I'm going to start with a concentrated solution, and this might be a 6 molar solution. So the question is, what volume do I need to pour in here in order to make the solution? And then what I would do is once I get that volume, I would then add the rest water. And then that's where the dilution would come in. Okay? So that's the background information on dilution. So let's take a look at just some notes here. Again, this is the same thing I just pretty much talked about. Keep in mind that during the dilution process, the number of moles of solute remain constant, and therefore I can get this equation and I can solve for various components. I can either solve for new volumes or new molarities, depending on the particular problem. Now, concentrations volume can be in any unit as long as they are consistent. So that doesn't, you could have milliliters, you can have liters, and typically if you multiply volumes times the molarity, you want to have your volume in liters, because otherwise they won't cancel. But because you might have volumes in here, it'll be okay. And I'll show you in some problems that we do in class what that last part means. All right, so let's take a look at an example. All right, so let's say I have a solution, or I have what volume of 16 molar sulfuric acid. So I'm going to draw a little picture here. What I have here is my 16 molar acid. So this is my molarity. Okay, I'm looking for what volume of this do I need to add. What I'm going to do is I'm going to make a solution over here. What I want this solution to be is I want the volume to be 1.5 liters, and I want the molarity of this solution to be 0.10 molar. Okay, so I'm making this solution. That's what I'm doing. I'm making this solution here. What this is telling me by having these two pieces of information is telling me how many moles I should have in this container. Keep in mind, when we have volumes and molarities, it is telling the chemist how many moles they're putting in solution. So the real question here is, okay, this is my starting solution. How much of this do I need to pour in here to get started? Let me go back and show you what I'm talking about. In this here, this is what I'm answering, this part right here. How much of this do I have to add into the container before I do the dilution process? Okay? A lot of students get confused with what they're solving for when they're doing these problems, because they just kind of plug into the equation. So I'm going to call this the 2, call this a 2. You can call it whatever you want. You don't have to call it a 1 and a 2. You can call it A and B and B and B. Whatever you want to do, it's up to you. But all right, so when I use this equation, M1 V1 equals M2 V2, what I do is I solve for V2. So V2 is equal to M1 times V1 over M2. So I just plug in my information. My molarity is 0.10 molar. My volume here is 1.5 liters. And I divide that by my 16 molar. And what I end up with is 0.0094 liters. Okay, if you want, it might be better to put that in 9.4 milliliters, but it's up to you. Doesn't matter, because it doesn't tell me, it doesn't say what the volume has to be. All right, notice that the molarities cancel. So if this were in milliliters, you could leave it, because it's, you don't have to worry. You're not really truly multiplying these out, and that's what I meant by that before. Whatever this unit is irrelevant, because these units cancel out. More on that later. So what I'm going to do is I'm going to take that solution and I'm going to pour some of this solution into here. How much am I going to pour? I'm going to pour in here really small amount. I'm going to pour that 0.0094 liters into the container. Okay, that is of this solution, right? It is 16 molar. So as of right now, this is pretty concentrated. This is a 16 molar solution. What I have to do now to do the dilution, I haven't really diluted anything down. What I have to do now is I have to add water and then do the diluting process. And be careful, because I'm going to ask you questions about how much water you're going to need. What you want to do is add water until your final volume is equal to 1.5 liters. All right, and when you do that, as you add that water, you're going to change the molarity from 16 all the way down to 0.1. And that's why we need a lot of water. We're going to add a lot more water than we are going to have of the concentrated solution. All right, so that would be the process of diluting and an example problem. We'll definitely look at more in class, and I will see you guys later.